All right, we are looking at the back page of 2.6. So we're doing fundamental theorem of algebra problems here. We just got done with a bunch of these other ones on the front page. So let's go ahead and rock and roll through these ones. These are going to be pretty easy because we have our handy graphing calculator, and we can find the zeros pretty quickly from here. All right, let's start off with x to the third plus 5x squared minus 4x minus 60. So we graph it out on our calculators. X to the third power plus 5x squared minus 4x minus 60. Okay, graph. Do we have any free zeros that they give to us? Yeah, it looks like we got one over there at positive 3. Let's check the table to make sure. All right, positive 3. Yeah, sure enough, we have a 0 right over there. And it looks like that's the only one that we have. So we're going to kind of merge our idea of using the graphing calculator and then the method that we went over from here with using the quadratic formula to make this pretty easy. So we already know that, once again, 3 is going to work. So we put 3 in the corner because that's one of our zeros. X equals 3, that's one of them. And we're looking for a grand total of 3 of them. So we have 1x to the third, 5x squared, negative 4x, and negative 60. So 1 times 3 is 3, 5 plus 3 is 8, 8 times 3 is 24, 24 minus 4 is 20, 20 times 3 is 60, and sure enough we get, as a remainder, 0. So that means it's a 0. So now, since I don't see any other zeros here, I'm going to stop my synthetic division, and I have a quadratic here, because this is my constant, this is my x squared, so I have 1x squared plus 8x plus 20, and that gives me an a value of 1, a b value of 8, a c value of 20. So I plug it into the quadratic formula and find my other two zeros. It'll always give you two zeros unless you have a perfect square, which in that case you should, see something different on your calculator that allows you to, use that as a zero a couple times. But anyways, so you have negative b, negative 8, plus or minus the square root of 8 squared minus 4 times 1 times 20, all over 2 times 1. Okay, so we get negative 8 plus or minus the square root of, and let's see, that's 64, and 4 times 20 is 80, so minus 80. 64 minus 80 is negative 16, so we have negative 16 under there. Whoa, so that's even going to be an imaginary solution. That's pretty crazy. And then 2 times 1 is 2. All right, so we get negative 8 plus or minus, and then we move the negative out front, so we have an I in its place, and then square root of 16 over 2. And then the square root of 16 is just 4, so that means that this all turns into negative 8 plus or minus I times 4, or 4i. Let's write that a little bit better. 4i over 2. And then you can reduce it a little bit further because 8 and 4 both divide by 2, so that turns into negative 4 plus or minus 2i. So those are your other two solutions, your other two x-intercept values. You have negative 4 plus 2i, and then also negative 4 minus 2i. That's 1, 2, 3 zeros, and we're all done. All right, let's move on to the next one, number 9. So number 9 is going to be very similar. We graph it out first, so clear that out. X to the third power plus 9x to the second power plus 36x plus 54, graph. And we have a 0 at, looks like negative 3. And it looks like it's probably it. Let's see if that's even a 0 there at negative 3. Yeah, it is. Okay. So we have at least one step that we can start off. So negative 3 goes in the corner. And then we have 1x to the third, 9x squared, 36x, and 54. So again, we're expecting it 0 for our remainder. Let's see if that's the case. 1 times negative 3 is negative 3. 9 minus 3 is 6. 6 times negative 3 is negative 18. 36 minus 18 is 18. 18 times negative 3 is negative 54, and sure enough, we get 0. So that gives us a quadratic that's x squared plus 6x plus 18. This doesn't factor, so again, we're going to have to use quadratic formula. So a equals 1, b is equal to 6, c is equal to 18. Plug it into the formula. Negative of 6 plus or minus the square root of 6 squared minus 4 times 1 times 18. That's going to be another imaginary one, I believe. And then we have over 2 times 1. All right, so negative 6 plus or minus the square root of, and let's see here, that's 36 minus 72, so that's negative 36. Yep, imaginary. All over 2. So the negative moves to the front, becomes an I. So we have negative 6 plus or minus. Square root of 36 is also 6, so we get 6I over 2. Divide both of those by 2, and you get negative 3 plus or minus 3I. So now we have all three of our zeros. We have negative 3. We also have negative 3 minus 3I, and negative 3 plus 3I. So 1, 2, 3 of them, 3 zeros. All right, moving on to the last one, number 11. So for number 11, I'm going to go ahead and type that in first from my graphing calculator. X to the 4th power plus 13x to the 3rd power minus x squared minus 13x. Graph. All right, let's see what our zeros are. All right, looks like we've got negative 1, 0, and 1. Let's verify that on our table. Yeah, negative 1, 0, and 1. That's 3 of them, but I have 4 that I'm supposed to find. Okay, let's try and see what we can get with this. So we at least know 3 of the zeros. So let's use negative 1, 0, and 1 with our synthetic division. So here we go. We have negative 1. We're going to try that one first. So we have 1x to the 4th, 13x to the 3rd, negative 1x squared, negative 13x, and then a placeholder for the constant, 0. We should end up with 0 for our remainder. Let's see if that works. 1 times negative 1 is negative 1. 13 minus 1 is 12. 12 times negative 1 is negative 12. Negative 12 and negative 1 make negative 13. Negative 13 times negative 1 is 13, and 13 minus 13 is 0. 0 times negative 1 is 0, and 0 plus 0 is 0. Okay, so that one checks out. So one of our zeros is negative 1. Now let's check out the next number. So again, from our table, 0 is another 0. So we plug in 0 over here, and let's see what we get with that. Should end up with the remainder of 0. Let's verify that that's the case. So 1 times 0 is 0. 12 plus 0 is 12. 12 times 0 is 0. Negative 13 plus 0 is negative 13. Negative 13 times 0 is 0, and 0 plus 0 gives us 0. Yep, so that one works out. All right, and then our last one that we have on the graph is 1. So let's plug in 1 for synthetic division, and the corner it goes. And we should end up with a remainder of 0. Let's see if that's the case. 1 times 1 is 1. 12 plus 1 is 13. 13 times 1 is 13, and 13 minus 13 is 0. Okay. But those are the only ones that show up on our graph immediately. So what do we do from here? Well, we kind of do the same thing that we did over here, where we write out the polynomial that we have, we set it equal to 0, and solve for it. Let's see what we have. So this is the constant, this is the x. So all we have is just 1x plus 13, that's it. So we set it equal to 0 and solve it. So how do you solve that one? You just subtract 13 from both sides, and you get your last 0, negative 13. And you can even check it out on your graphing calculator. We didn't look for it, but I bet that, opposite direction, negative 13. So if we go to negative 13, it should be 0. Yeah, check it out. It's 0. All right, so that gives us our last 0, negative 13. That's 1, 2, 3, 4 zeros and a degree of 4. So that's our answers. Those are our zeros. And that's it. So, that's all of 2.6. If you need some help with fundamental theorem, just make sure you reach out for it. All right, that's it.